So in this video, we'll be looking at TMUA integration to find regions. So the questions that like, what's the region enclosed by this? There are only two steps that you need to know here. The one is to sketch. When am I ever going to make a TMUA video and never mention sketching? That's never going to happen. I'm always going to mention it. And then you just integrate. As long as you do these steps in this order, you should be fine. This question is very easy because you're given the sketch, so you don't have to go through the arduous and incredibly difficult proposition of actually remembering to sketch something. So okay, they've given us the sketch, they're telling us that this region is equal to this one, and this is a quadratic that passes through here and here. That means in factored form I could write it as x minus 2x minus q. I could expand that out just to make it easier to integrate, and it looks like this. Now if the region R is going to be the integral between 2 and 0 of this, and the region S is going to be integral between q and 2, and you could do this minus this to make 0, except that wouldn't quite work, because of course remember this integral is going to give you a negative value because it's below the axis, so you actually do this plus this to give you 0, but actually there's a much easier way of doing this anyway, which is to say, well, if this area is equal to this one, this is going to give you a negative if you integrate, so if I just integrate between q and 0, the entire integral will be 0, because these two things will cancel. So I can just integrate between 0, and as soon as you make that awareness, then this is fine. And again, if they hadn't given you the sketch, if you had sketched that, you could have seen that. So if they don't give you a sketch, just sketch it. I won't go through the algebra particularly deeply here because it's just very straightforward. You know that q isn't 0 because it tells you so you can divide by q squared there, and you get the answer very quickly. Good, next question. So question number 14 from 2020, the exam papers are all up here somewhere. We've got a line and a curve x cubed. Sketch it. That was the first instruction, wasn't it? This is a line with 0 y-intercept, and this is a curve which kind of does this. It doesn't really matter whether m is positive or negative, because if it was negative, it would just go this way and we get no regions. So that wouldn't make sense. So we definitely know m is positive. We can just conclude that from the sketch. Now it says that the region enclosed is 6. Now of course we've got two regions enclosed, but by symmetry they must be equal. So this region is just 3. And now I just need this intersect by setting, which I get by setting this equal to this. I can divide by x because I know x is 0 as a solution to the intersect of the two things. That's fine. So I get other intersects at root m and minus root m. And of course, I only need to find this area because I know it's equal to this one. So I'll integrate between root m and 0 of this curve will give me the area underneath it. But if I just do the triangle here, because you never have to integrate straight lines, just do triangles or trapeziums. This triangle is going to be height m root m, base root m, so it's going to be half times root m times m root m is the triangle. Take away the integral between 0 and root m of this curve, and that's equal to 3. And again, from here the algebra is very straightforward, just do it, and you're going to get an answer eventually, and you just do some stuff, and you get it, good. So the sketch is what's important here. Again, at this point, just take over, do it yourself. You just need to make sure you sketch this every time. That's the first instruction that I put on the board, isn't it? So sketch this. This one well, both of these aren't trivial to sketch, but let's rearrange this one for y equals first, I guess. Divide by p and then square both sides. And that's just a quadratic, centered at 0, 0. So that's easy to sketch. This one here, I would recommend you just know what the graph of root x looks like. The graph of plus minus root x looks like this, but this is only the graph of plus root x, where p is some positive constant, so it's just we're just looking at the positive bit here, so we ignore the negative bit, and just know that the y equals root x graph looks like this would be my main advice. There are various reasons to explain why it looks like that, but it's just much quicker to go into the exam knowing it. So again, we're looking for this region here. We look for the intersect first between this thing and this thing, so we set them equal to each other. This clearly intersect is 0, of course, the sketch tells me that, and so does the algebra. If you put in 0, 0, they both work. Times by p squared. Divide by root x. This is x to the power of half. Take away the powers to get this. You can cube root both these if you want to, or you can square both, and then you can cube root. It's not really going to make a difference which one you did there, in which order. So this intersect is at p squared. You can substitute p squared into either one of these things. It doesn't really matter. And actually, we don't need to do that at all, do we? Because all we need to do is do the integral of this one, which was the rooty one, between p squared and 0, and take away the integral of this one, which was this one between p squared and 0. Nice little trick here. If you're doing two integrals between the same two things, you can just shove them together. But I didn't do that because I couldn't be bothered, apparently. This is x to the power half, so it integrates to that, and then you divide, call. Again, I said I wouldn't go through the algebra too carefully. This is a bit confusing because there's p's here and here. So you put the p into there, p squared to this power, the 2's cancel, and you get p cubed, times p is to p to the 4, and same kind of thing over here. And we eventually get our answer, which is one of the options there. Good. Another one then, so again, this is just sketching. This is what I've said, isn't it? Sketching. This is a 1, 2, 3 quartic graph. It's a negative quartic because one of the x's is negative. So it's going to come down from here and here. It's got roots at 0, p, q, and r. and those are all positive numbers in this order, P, Q, and R in that order. Good, it's a upside down quartic as I said, so it's going to go through like this. And the graph looks a bit like that. The integral between R and 0 is 0. So if I call this region A, B, and C, I can say that A plus B plus C is equal to 0, where B is a negative area. I guess I'm saying that. B is a negative number. I'm just saying this area is a negative number. Okay, the integral between 0 and Q is minus 2, so A plus B is minus 2. But I can immediately see from this that C, if A plus B is minus 2, C must be 2 to cancel this out. So C is equal to 2. And then here, between R and P, so B plus C is minus 3. But if C is 2, that makes B minus 5, which is good because I want it to be negative. And then if this is this and this is this, then I can get that A is equal to 3. 3 plus 2 is 5, minus 5 is 0. And what's the area between 0 and R? The total area, and just be careful here, it's tempting to look at this and go, well, the total area is 0, right? Between 0 and R, it's just 0. But when it says total area, it means actual area. It doesn't mean the value of the integral, which of course counts things down here as negative. It means the actual physical area between 0 and R, and that's going to be A plus the modulus of B, the positive number B, plus C. So 3 plus 2 plus 5, which will give us 10. Last question, couldn't resist throwing in a paper 2 thing here. F of x is increasing, so it looks a bit like this function. Like it's just increasing. It's just always increasing like this. F of 0 is equal to 0 means that I have plotted this terribly, but I don't think that matters too much. So I'm just going to pretend to go with it because I don't care enough to change this now. Let's see if that matters. I don't think it does. The area of the region enclosed by the curve, it won't for my picture, but just be aware to follow instructions, but it won't matter for my picture. This region is R, and you take this other function that's f of x, so the function itself, plus, well, this is just a constant, right? F of b is the function evaluated somewhere, so that's just a number. Times by 2 is just a number. So we're just lifting this graph up by quite a distance. In fact, we're lifting up by 2 lots of this distance here, f of b. So we take this distance, we times it by 2, and lift it up that far. And what we're asking is, what's the new area between, so this is g of x, the new curve, what's this new bigger area in terms of r? And the easiest way to do this, I think, is just to say, well, if I just picked up r and put it up here, so pick up this r, put it up here, all that's left below is a big box, and that big box has width b minus a, and because this total distance is 3 lots of f of b up to here, another 2 up to there, so that whole distance is 3, there's one of them here, because that's the original one here, there's 2 left, so that area of this box here is just b minus a times the 2 f of b left over here. And so we just get r plus 2 b minus a, so 2 times b minus a times f of b, and the answer is b. Yeah, this drawing didn't really make a difference here, but I guess it does if because what it's saying is that you can't make a way back here to get a negative number there, which would mess it up. So that's why they wanted you to put f of 0 at 0, but it didn't make a difference for my picture. But yeah, anyway, cool. Thank you for watching. I'll see you next time.